Hi students, welcome to Sunil's tutorial. I'm Sunil Nirvani and today we'll be doing this chapter called as electrons and photons. Take down a sum please. The energy in a photon is 2 electron volts. The energy in a photon is 2 electron volts. Find the frequency and wavelength. Find the frequency and wavelength. Find the frequency and wavelength. Now let's see this. Velocity of light in air you are supposed to know by heart, 3 into 10 raised to 8 meters per second. Moreover, you are supposed to know Planck's constant by heart, that is 6.63 into 10 raised to minus 34 joules second. Right? Now, what have they asked you to find out? They have asked you to find out frequency and wavelength. I can say that frequency is nothing but energy upon Planck's constant. Right? So, you have energy, you know Planck's constant, you should be able to get the frequency. Wavelength. Wavelength is velocity of light divided by frequency. Right? Both the values you have, you should be able to get this answer. The answer for this should be frequency is 4.826 into 10 raised to 14 Hertz. Wavelength is 6.216 into 10 raised to minus 7 meters. Fine, we get this thing here. Next, take down next sum please. The photoelectric work function of tungsten. The photoelectric work function of tungsten is 4.5 electron volts. The photoelectric work function of tungsten is 4.5 electron volts. Calculate the threshold frequency and the threshold wavelength. Calculate the threshold frequency and the threshold wavelength. Calculate the threshold frequency and the threshold wavelength. You are supposed to know the value of H by heart. H is 6.63 into 10 raised to minus 34 joules second. Remember, when they give you an electron volt, you have to convert it into joules. The conversion factor is multiplied by 1.6 into 10 raised to minus 19. Okay. Once you have this, then I can say that work function is nothing but H into V0. Work function is Planck's constant into threshold frequency. So you should be able to find out the threshold frequency now. I can say that threshold frequency is work function upon H. Next, they also ask you to find out wavelength. Threshold wavelength is velocity of light in air upon threshold frequency. Right? The answer for this should be threshold frequency you should get as 1.086 into 10 raised to 15 Hertz, and threshold wavelength is 2762 Armstrong units. Right? Take on next one please. The photoelectric work function. Yeah. See, velocity of light in air.
Okay.
3 into 10 raised to 8 meters per second. Right? Next, the photoelectric work function. Of a photosensitive material. The photoelectric work function of a photosensitive material is 4.8 into 10 raised to minus 19 joules. Calculate the threshold frequency Calculate the photoelectric work function of a photosensitive material is 4.8 into 10 raised to minus 19 joules. Calculate the threshold frequency and threshold wavelength. Calculate the threshold frequency and the threshold wavelength. Guys, we know that Planck's constant is 6.63 into 10 raised to minus 34 joules second. Velocity of light in air is 3 into 10 raised to 8 meters per second. Replica of the previous sum. You use the same formula that you have in the previous sum and solve the sum, right? That is, you will have to use the formula work function is h into v0 and lambda 0 is equal to c upon v0. Use the same formulas. Use the same method that you used in the previous sum and solve this. The answer for this you should get as threshold frequency should be equal to 7.24 into 10 raised to minus 14 hertz, and threshold wavelength is 4144 into 10 raised to minus 10 meters. Next, take the next sum please. Calculate the threshold frequency, threshold wavelength. Calculate the threshold wavelength. Calculate the threshold wavelength. If the threshold frequency is 5 into 10 raised to 14 hertz. If the threshold frequency is 5 into 10 raised to 14 hertz. Now we already know that the velocity of light in air is 3 into 10 raised to 8 meters per second. So therefore I can find out the threshold. What is the asked to find out? Threshold wavelength. Threshold wavelength is c upon v0. The answer for this sum should be 6000 Armstrong unit. Right, take on next sum please. An aluminium metal has a threshold frequency. An aluminium metal has a threshold frequency which corresponds to a wavelength. Has a threshold frequency which corresponds to a wavelength of 4770 Armstrong unit. 4770 Armstrong unit. Calculate the photoelectric work function of aluminium. Calculate the photoelectric work function of aluminium. Now, we know that Planck's constant is 6.63 into 10 raised to minus 34 joules second, and velocity of light is 3 into 10 raised to 8 meters per second. Now, let's see this. They've asked you to find out threshold frequency. We've been using the same formula all along. We've been using the formula threshold wavelength is c upon threshold frequency. All you have to do is just revert the formula. So I can say threshold frequency is c upon threshold wavelength. So you should be able to get the threshold frequency. What else have they asked you to find out? Work function. Work function is Planck's constant into threshold frequency. So once you get threshold frequency, you should be able to get that answer. The answer for this should be work function is 4.17 into 10 raised to minus 19 joules. Next, take down next one please. The longest wavelength of a photoelectron, the longest wavelength of a photoelectron is 1950 Armstrong units. Is 1950 Armstrong units, which is nothing but 1950 into 10 raised to minus 10 meters. Right? Let's say that calculate the work function. Calculate the work function. Calculate the work function. Now, threshold wavelength is given to you, Planck's constant is given to you, velocity of light in air you should know by heart. They've asked you to find out, calculate the work function. First, let's get the threshold frequency, replica of the previous sum. Threshold frequency is velocity of light in air upon threshold wavelength. Then they've asked you to find out work function. Work function is nothing but Planck's constant into threshold frequency. So this is hc upon lambda 0. You know c, you know lambda 0, you know h. You should get the answer. The answer for this should be 10.2 into 10 raised to minus 19 joules. There's one more thing. Suppose if they ask that give the answer in terms of electron volts, how do you convert this into electron volts? Just divide by 1.6 into 10 raised to minus 19. You should get the answer in electron volts, right? You divide this by 1.6 into 10 raised to minus 19, you will get your answer in electron volts. So the same answer could also be given as 6.375 electron volts. This is specifically important to you when you get it in terms of objectives in your paper or when you are doing CET. They may give you the answer in terms of electron volts, so you should know the conversion factor, right? Next, take on next one, please. Calculate the energy. Calculate the energy in a light of wavelength. Calculate the energy in a light of wavelength 5000 Armstrong unit and express it in electron volts. And express it in electron volts. Now, we know that velocity of light in air is 3 into 10 raised to 8 meters per second. We also know that Planck's constant is 6.63 into 10 raised to 34 joules second. Now, once you have this, then you can find out frequency. Here, instead of using threshold frequency, you will just call it as frequency. Frequency is velocity of light in air upon wavelength minus 34. Next, you can also say that energy. They've asked you to find out the energy. Energy is nothing but hv, Planck's constant into frequency. Right? This h is 10 raised to minus 34. Okay. So you will get your answer of energy as well as the frequency. You should get your answer as 3.978 into 10 raised to minus 19 joules. Right? Next, take on next one, please. The photoelectric work function. The photoelectric work function of a metal. The photoelectric work function of a metal is 2.4 electron volts. If a light of wavelength 5000 Armstrong units, if a light of wavelength 5000 Armstrong units is incident on the surface, find the threshold frequency. Find the threshold frequency and also state if there will be emission, and also state if there will be emission. Velocity of light in air is 3 into 10 raised to 8 meters per second. H is 6.63 into 10 raised to minus 34 joule second. Now, once you have this, first let's find out the threshold frequency. Threshold frequency is nothing but work function upon H. Right? You already know work function, you know H. So you should be able to get your threshold frequency. Right? Now let's also find out the incident frequency. The incident frequency is going to be nothing but velocity of light in air upon lambda. Right? Velocity of light in air upon lambda. Once you have these two, you have to compare the incident frequency with the threshold frequency. If the incident frequency is more than the threshold frequency, then there will be emission. If the incident frequency is less than the threshold frequency, there will be no emission. Okay? In this case, your answer should be, in this case, your answer is going to be you will get your threshold frequency as 5.792 into 10 raised to 14 Hertz. You will get incident frequency as 6 into 10 raised to 14 Hertz. As incident frequency is greater than threshold frequency, therefore there will be emission. That's how you find out whether there will be emission from a photoelectron or photometal, photosensitive metal. Fine, do we get this thing there? Take down next one, please. The work function of a metal, the work function of a metal is 2.4 electron volts. The work function of a metal is 2.4 electron volts. Wavelength of 6,800 Armstrong units. Wavelength of 6,800 Armstrong units is incident on the surface. Find the incident and threshold frequency. Find the incident and threshold frequency. And state if there will be emission. And state if there will be emission. And state if there will be emission. It is identical to the previous sum, guys. So I'm not solving it, I'll just directly give you the answer. Look at the previous sum, it's replica of the previous sum. Only the numbers have been changed. Your threshold frequency should be equal to 5.818 into 10 raised to 14 Hertz. Your incident frequency should be equal to 4.412 into 10 raised to 14 Hertz. Then you would say as incident frequency is less than the threshold frequency, therefore there will be no emission. Next, take down next one, please. The photoelectric work function. The photoelectric work function. The photoelectric work function of a metal, the photoelectric work function of a metal is 3 electron volts. Find the maximum kinetic energy and maximum speed. Find the maximum kinetic energy and maximum speed of photoelectrons when a light of 4000 Armstrong units, when a light of 4000 Armstrong units is incident on the metal surface, if the mass of the electron is 9.1 into 10 raised to minus 31 kgs. Now guys, we know that velocity of light in air is 3 into 10 raised to 8 meters per second. We also know that Planck's constant is 6.63 into 10 raised to minus 34 joule second. Now, what have they asked you to find out? They have asked you to find out maximum kinetic energy. Maximum kinetic energy I can find out by using Einstein's equation. I can say that maximum kinetic energy will be the total energy minus the work function. Total energy is nothing but hv minus the work function. B is nothing but c upon lambda. Incident frequency is nothing but velocity of light in air upon wavelength minus work function. They have directly given you, so I don't need to convert. H, C, lambda, you know, so you'll come to know maximum kinetic energy. So you'll come to know maximum kinetic energy. This is the first part of the question. But maximum kinetic energy is given by the formula half mv square. We will take this as velocity, right? Velocity square. Since kinetic energy is maximum, velocity will also be maximum. Therefore, I can say that v square is twice max ke divided by m. Therefore, I can say that maximum velocity of electrons is going to be square root of 2 maximum kinetic energy upon mass of the electron. Mass of the electron is given to you. Maximum kinetic energy you found out, so you should get this answer. The answer for this sum should be max kinetic energy is nothing but 1.725 into 10 raised to minus 20 joules, and maximum velocity Vmax should come out to 1.947 into 10 raised to 5 meters per second. Next, take on next one please. The threshold wavelength of silver, is 3800 Armstrong units. The threshold wavelength of silver is 3800 Armstrong units. Calculate the maximum kinetic energy when a light of wavelength 2600 Armstrong units falls on it. When a light of wavelength 2600 Armstrong units falls on it. Now guys, by Einstein's equation I can say that maximum kinetic energy is equal to hv minus work function, right? But V is nothing but C upon lambda. Before that I can say that work function is hv0. Work function is nothing but Planck's constant into threshold frequency, h common. I can say that this is V minus V0. But V minus V0 I can say is nothing but V is nothing but C upon lambda. So this is H C upon lambda minus C upon lambda 0. Therefore this is going to be HC 1 upon lambda minus 1 upon lambda 0. Right? So when you solve this, you have all the values. You have HC which are constants, and lambda 0 are given to you. So you should be able to get the maximum kinetic energy. Once you get the maximum kinetic energy, they have also asked you to find out the velocity of the electron. Max kinetic energy should be equal to half mass of the electron into velocity square of the electron, max velocity square of the electron. Therefore I can say max velocity of the electron is going to be twice maximum kinetic energy divided by mass of the electron, square root, right? So in this case you also have to consider the mass of the electron as constant, which is nothing but 9.1 into 10 raised to minus 31 kgs. I can say where mass of the electron is 9.1 into 10 raised to minus 31 kgs. So you have max kg, you should be able to get the maximum velocity. The answer for this sum should be max kinetic energy is 2.416 into 10 raised to minus 19 joules, and Vmax is 7.287 into 10 raised to 5 meters per second. Fine. Next, take on next one please. The threshold frequency of a certain metal, is 1.7 into 10 raised to 15 Hertz. The threshold frequency of a certain metal is 1.7 into 10 raised to 15 Hertz. Light of frequency 2.2 into 10 raised to 15 Hertz is incident on the metal. Next, the kinetic energy of photoelectrons is 3.3 into 10 raised to minus 19 joules. You have to find Planck's constant. Find Planck's constant. Now guys, by Einstein's equation, kinetic energy is equal to hv minus work function, hv minus hv0, h common, v minus v0, kinetic energy. So therefore I can say that h is equal to kinetic energy upon v minus v0, right? Simple straightforward sum. You should get your answer here as 6.6 into 10 raised to minus 34 joule second, right? Okay, we will stop this here for the day. Thank you very much.